Welcome to this learning workshop on the essentials of plastics brought to you by We Recycle. Over the next few minutes, we will explore where plastics come from, how they are classified, what happens when they are not properly managed, and, most importantly, what each of us can do to be part of the solution. But first, a word about who we are. We Recycle is an NGO founded in 2016 with a clear mission: to educate, to collect for recycling, and to help shape the policies and programs that will keep Mauritius clean and green. Our work is built around three core activities: collection, education, and advocacy. We operate a network of public eco-bins in the west and south of the island, as well as specific collection points in Williams, through which we remove recyclable plastics and aluminium cans from the solid waste stream. We run educational programs in schools, universities, and companies, and we deploy activities and projects in local communities to raise awareness on waste sorting and sustainable consumption. Let us begin by discovering plastics. So, what exactly are plastics? Plastics are a wide range of synthetic or semi-synthetic materials whose main ingredient is polymers. They can be molded, extruded, or pressed into solid objects of virtually any shape. They are lightweight, durable, flexible, and relatively inexpensive to produce, properties that have made them indispensable in modern life. Most plastics are derived from fossil fuel-based chemicals, such as natural gas or petroleum, although more recent methods use derivatives from renewable materials like corn or sugarcane. The word plastic itself comes from the Greek word plastikos, meaning capable of being shaped or molded. At the heart of every plastic is a polymer, long, repeating chains of smaller chemical units called monomers joined together through a process called polymerization. How did plastics become the all-pervasive material of modern society? The story begins in the late 1800s when plastics were first developed as an alternative to natural resources like ivory, which were being depleted through overexploitation. Celluloid, the first synthetic polymer, was invented during this period. By the early 1900s, fully synthetic plastics were emerging. The most notable was bakelite, the very first fully synthetic plastic, which was soon followed by innovations like the Scotch tape and new thermosetting tableware. From 1930 to 1950, plastics proved their worth, especially during World War II, used extensively in nylon, aircraft canopies, and military equipment. This wartime utility drove mass industrial production. In the 1950s, the range of applications broadened dramatically. PVC blood bags, polyester clothing, the Lego and Barbie toys all appeared in this decade. The following decades saw plastics invade every aspect of daily life, from acrylic paints and Kevlar fabric in the 1960s and 70s to HDPE pipes, PET beverage bottles, and the first double-glazed PVC windows. The story of plastics did not stop there. Today, nanotechnology and the aerospace industry pushed the boundaries further. The Airbus A380 is made of 20% carbon fiber reinforced plastics, and the Boeing 787, nicknamed the Plastic Dream, is composed of 50% plastic materials by weight. Looking beyond, researchers are exploring plastic solar cells, 3D printed body parts for transplant patients, implantable polymers to treat neurological conditions, and plastics that mimic hemoglobin for emergency medicine. Tomorrow's driverless cars will be constructed almost entirely from plastic components. Plastics, for better or for worse, are woven into the fabric of our civilization. Now, let us look at the different categories of plastics. Not all plastics are the same. To help consumers and recyclers identify them, The resin identification coding system was introduced in 1988 by the Society of the Plastics Industry. Since 2008, it has been administered by the ASTM International. You may have seen the number triangle on the bottom of plastic objects. This number identifies the type of resin used. A word of caution. Many people assume that the recycling symbol means the item is being recycled. In reality, it only indicates the resin type. In principle, all plastics can be recycled. In practice, however, it depends on several factors: economic viability, the mix of chemicals in the item, the level of contamination, and the cost of transport. Many plastics that are technically recyclable are unfortunately not recycled in practice. The first category that we will look into is PET, or polyethylene terephthalate, the clear, strong plastic used in beverage bottles and synthetic fibers. In Mauritius, PET is collected, sorted, and baled for export, primarily to South Africa. The second category is HDPE, or high-density polyethylene, one of the most versatile plastics, known for its high tensile strength. Both PET and HDPE are collected in Mauritius for recycling. The third category is PVC, polyvinyl chloride. It is used in window frames, drainage pipes, electrical cables, flooring, and even medical blood bags. PVC is highly durable and versatile, but it is not currently collected for recycling in Mauritius. The fourth category is LDPE, low-density polyethylene, the thin, flexible plastic used for shopping bags, cling wrap, and food packaging. LDPE is indeed collected locally for recycling. The fifth category is polypropylene, or PP. It is a semi-rigid material resistant to heat and chemicals. It is used for making chairs, buckets, food containers, automotive parts, and carpets. PP is collected for recycling in Mauritius. Category number 6 is polystyrene. It comes in two forms, rigid and expanded foam. It is used in packaging, yogurt pots, and toys. Because of its low density and its tendency to break into small pieces, it is not currently collected for recycling locally. Finally, the last category is a catch-all for all plastics not covered in the first 6 categories. It includes polycarbonates, ABS, melamine, and bioplastics. Items in this group are often made of mixed resins, making recycling extremely difficult. This category is not collected for recycling in Mauritius. This category also includes bioplastics, that is, materials derived from biological sources such as cornstarch or sugarcane, which leads us to an important distinction. Three terms are often confused: biodegradable, compostable, and recyclable. A biodegradable plastic breaks down through the action of microorganisms in the environment. However, there is no fixed time limit, and the process can leave behind toxic residues depending on the material. A compostable plastic degrades under specific controlled conditions, the right microorganisms, heat, and humidity, breaking down into water, carbon dioxide, and biomass with no toxic residue. Importantly, compostable plastics are designed for industrial composting facilities, not household bins or landfills. Placed in a landfill, they will not biodegrade as intended. Recyclable plastics, on the other hand, are reprocessed into new products. It is very critical to understand that compostable and biodegradable plastics should never be mixed with recyclable plastics, as they can contaminate and disrupt the entire recycling stream. So, what happens to plastics after they are collected? We Recycle collects four types of plastics: PET, HDPE, PP, and LDPE. PET is exported mainly to South Africa, where it becomes textile fibers. HDPE and PP, the hot plastics, are recycled locally by companies such as Surfrider, DKD, and PIM Recycling Limited. They are transformed into outdoor furniture, electrical pipes, bins, and pallets. LDPE, the soft plastic, is also recycled locally, made into trash bags, charcoal bags, fertilizer bags, and agricultural black plastic films. One condition applies across the board: cleanliness. Contaminated plastics are refused by recyclers. Before placing any plastic in a recycle bin, make sure there is no residual product left in it. But what is the cost of getting this wrong? The total cost of solid waste management in Mauritius is estimated at 2.37 billion rupees per year. In 2024, approximately 540,000 tons of solid waste were disposed of at the Moshiko's landfill. Of that, around 14% consisted of plastic waste. Yet, only up to 4% of that waste is actually recycled locally or through export. More than 90% of waste sent to Moshiko's comes from households. This means that our individual daily choices have a direct impact on how much ends up in the landfill. The government has earmarked over 400 million rupees for the vertical expansion of Moshiko's between 2023 and 2026. As taxpayers, we are all footing that bill. We are well aware that the Moshiko's landfill has long passed its saturation point. We have seen the fires that took more than a month to be extinguished. Transfer stations across the island are under pressure, too. Vertical expansion may buy us some time, but it is not a long-term solution. Mauritius is a small island. We have finite space. If we continue generating waste at the current rate, we will eventually have nowhere left to put that waste. The question we must ask ourselves is, what happens to our waste once the transfer stations are full? Let us now look at the real-world consequences of plastic waste mismanagement. When plastics are not properly disposed of, they make their way through rivers, drains, and land surfaces into our oceans. This process affects every ecosystem, from the soil beneath our feet to the depths of the sea. In our oceans, plastics entangle marine animals, suffocate coral reefs, and are mistaken for food by fish, sea turtles, and seabirds. Microplastics, tiny fragments resulting from the breakdown of larger items, contaminate entire marine ecosystems, entering the food chain at every level. On land, wild animals become trapped in plastic packaging, ingest discarded items, or mistake plastic fragments for food. From deer to birds to small mammals, no species is immune to the consequences of plastic pollution. Plants too are affected. Studies have shown that microplastics are absorbed through the roots of vegetables, particularly root vegetables such as carrots and potatoes. Microplastics have also been found to disrupt photosynthesis, impacting plant growth and agricultural yields. And ultimately, the effects reach us. Microplastics have been detected in human blood, lungs, and even brain tissue. Exposure has been linked to hormone-related cancers, infertility, neurodevelopmental disorders, lung disease, oxidative stress, and inflammation. We eat, drink, and breathe microplastics every day through contaminated food, tap water, and the air itself. So, what can we do to be part of the solution? The answer lies in fundamentally rethinking how we consume. The waste management hierarchy gives us a clear roadmap. At the top, the most favorable actions, which are remember and respect, being mindful of our choices. Then come refuse, reduce, reuse, return, refill, rot, restore, repair, and repurpose. Recycling comes near the bottom of the hierarchy. It is the last resort before waste. And the very bottom, the least favorable outcome, is simply generating waste with no action taken. The hierarchy points us towards a circular economy where resources are kept in use for as long as possible and waste is minimized at every step. What does this look like in practice? Some examples that you can follow. Carry your own reusable mug instead of taking away single-use cups. Choose tap water instead of bottled water. Repurpose old tins and glass jars rather than buying new storage items. Opt for pencils made from recycled materials. Small everyday choices add up to a significant impact. There are also growing alternatives in Mauritius worth knowing about. For example, CNL offers refill stations for laundry liquid, dishwashing liquid, and hand soap. Thrift shops like the Good Shop offer second-hand clothing, accessories, and furniture. The company Sakili repurposes all banners into bags. And before discarding electronics, consider repair shops which can extend the life of your devices. When all other options have been exhausted, then we recycle. Sorting our waste correctly, separating plastics, paper, glass, and organic matter is essential. But recycling is not the starting point. It is the safety net. Here at the University of Mauritius, WeRecycle has installed sorting bins across the Réduit Campus to make it easy for students and staff to act. The red bin is for plastic bottles, water bottles, soft drink bottles, iced tea bottles. The yellow bin is for beverage cans. The blue bin is for all other waste. Please use them. Every bottle and can sorted correctly is one less piece of plastic heading to Moshiko's. We are all in this together. We often fall into what is called the triangle of inaction, waiting for the government to legislate or for companies to change their practices before we act ourselves. But the urgency of the situation does not afford us that luxury. As citizens and consumers, we have more power than we think. Our purchasing choices, our habits, and our voices shape the market and influence policies. We do not need to wait for someone else to go first. Time to act is now. Thank you for your attention. We hope this workshop has inspired you to look at plastics and at your own consumption with fresh eyes. To learn more about We Recycle, visit our website, follow us on Facebook and Instagram, or reach us directly by email. Together, we can make Mauritius cleaner, greener, and more resilient.